A circle is the set of all points in a plane that are equidistant from a fixed point called the center of the circle. Equidistant means they all have the same distance from that fixed point. Here the center is C, and the distance here, the fixed distance, is what we call r, or the radius. A line segment joining the center of a circle to any point on the circle is called a radius of the circle. The length of the radius, denoted by the letter r, is also usually referred to as the radius of the circle. So in other words, it's actually this segment that we call the radius, but its length is also referred to as the radius. So it's the word radius is used both for a segment and a length, which is usually not what we do in geometry, but we get away with it because we know what we're talking about, so it's okay. A line segment that connects one point of a circle to another point on the same circle is called a chord. Now, it doesn't necessarily have to go through the center, so a chord could go from this point to that point, right? But if it does go through the center, then it's called a diameter. So a chord can connect any 2 points on a circle, but a special chord that also goes through the center is called a diameter. And note that the length of a diameter is twice the length of a radius, right? So the relationship being that d is equal to 2r. All right. One thing to keep in mind here is that this little point we made in here, that we said all points in a plane, that's an important point, because think about what happens if we don't make that specification. If we just say all points that are equidistant from a fixed point, think about the geometric object that you would obtain by looking at all such points. It wouldn't just be a circle, would it? It would be an entire sphere. So if we said if we wanted to define a sphere, we would just say a sphere is the set of all points in space that are equidistant from a fixed point. So the specification that we're restricting ourselves to a plane is important, so that we only obtain the circle. Another thing to pay attention is the fact that when we talk about the area of a circle, for example, that's actually a misnomer, because the circle itself is a one-dimensional object, right? It's this distance around that you're seeing. So we're actually talking about the area of the disk enclosed by the circle. So that's really the correct way of thinking about that. But again, just like we use the word radius kind of loosely, we all know what we mean when we say the area of a circle. We mean the area of the disk enclosed by the circle. The most important form of the equation of a circle is the center radius form. It's the most useful form, just like, for example, when we were dealing with lines, the slope-intercept form was the most important form, because it gave us the most important information about a line. In the same way, the center radius form of the equation of a circle gives us the most important pieces of information about a circle. To obtain the center radius form of the equation of a circle, we apply the distance formula to the center C of hk and a typical point P of xy on the circle, keeping in mind that that distance is going to be the fixed distance that we call the radius, right? So we know that the distance between 2 points x1, y1 and x2, y2 is given by this formula. Remember from our previous lecture, we will apply this distance formula to the circle shown on the right here to obtain an expression for r. So we know that the square root of, if we think of this as x1, y1 and this point as x2, y2 for this formula, we end up with the square root of x minus h squared, right? Plus quantity y minus k squared equals r. Now, if we square both sides of that, the square root on the left side goes away, and we end up with just quantity x minus h squared plus quantity y minus k squared equals r squared. This last result is what we call the center radius form of the equation of a circle with center at C of hk and radius r. So this is a formula which we will be using quite a bit, so keep that in mind as we proceed. The first circle we'll look at is a famous one. It's called the unit circle, and if you continue your studies in mathematics and go on to calculus and beyond, you will be encountering this object quite a bit, especially in your trigonometry class and thereafter. So what we'd like to do now is go ahead and find the equation of the unit circle. So the unit circle is basically a circle of radius 1 whose center is just the origin itself, 0, 0. So applying our formula for a circle, which we know is, the center radius form, we get x minus h squared plus y minus k squared equals r squared. So now we're going to substitute 0 for h and also 0 for k. So we get x minus 0 squared plus y minus 0 squared equals, and we're going to substitute 1 for the radius r. So x minus 0 is of course just x. So we get x squared plus y squared equals, and we know that 1 squared is just 1. So there you have the equation of the unit circle. Alright, so let's go ahead and find the center radius form of the equation of a circle with center at -3, 4 and radius 6. You should pause the video and get it on your own and then compare your answer to mine. Alright, so once again we know that for a circle with center at hk and radius r, the formula is quantity x minus h squared plus quantity y minus k squared equals r squared. So replacing h with -3 and k with 4 and r with 6, here's what we obtain. Quantity x minus, here we're going to need another parentheses because we have to go minus -3 inside it, and then squared plus quantity y minus 4 squared equals 6 squared. So we end up with x plus 3 squared plus y minus 4 squared equals 36. Alright, and there is our equation of the desired circle. Okay, so very simple, but also very important. Make sure you know how to do these before we proceed. Go ahead and see if you can find the equation of this circle on your own. So the center is at 0, 0 and the radius is 3. Alright, so quantity x minus h squared plus quantity y minus k squared equals r squared. Here our h is 0 and our k is 0, so we get quantity x minus 0 squared plus quantity y minus 0 squared equals 3 squared. So that's going to simplify to x squared plus y squared equals 9. Similar to the unit circle, but of course with a larger radius you're going to get a larger number on the right side here. Okay, here we want to graph the circle with the given center radius equation. So obviously, in order to graph a circle, we're going to need to locate the center and the radius, right? So, and find the radius. So here we know that according to the center radius form, we have x minus h squared plus y minus k squared equals r squared. All right, so how would I be able to write x plus 3 as x minus a number squared? Well, I would have to go x minus negative 3 squared, right? Plus y minus 5 squared equals, and I want to write the 16 as a square as well, so that'll be 4 squared, right? So now I can extract my center and radius. So I know the center will be at negative 3 comma 5. If you've written the two expressions within the parentheses as a subtraction, then whatever comes after the minus sign in the first one is going to be your h, and whatever comes after the minus sign in the second expression is going to be your k. And your radius here is 4. So to graph it is pretty simple. You're just going to start at the center. Let me actually get a nice graph going here for you. Hold on. Okay, so we'll start at negative 3, 5. So starting at 0, 0, we're going to go left 3, up 5, right? That's going to be our center. As you know, of course, the center of a circle is not on the circle. All right, it's very important in defining the circle, but it's not one of the points on the circle, right? So the radius is 4. So a very easy way to graph these, if you're going to do it by hand, is to just go start at that point, go right 4 units. So go 1, 2, 3, 4, put a dot. Then go left 4 units. So 1, 2, 3, 4, put another dot. And then go back to the center and go up 4 units. So 1, 2, 3, 4. And then go down 4 units. So 1, 2, 3, 4. And then just kind of nicely connect those in a circular manner, right? Now, this is not going to look too pretty, but I just want to give you an idea on how you would do this by hand. There it is. Oh, that's very bad. Let me try one more time. Okay, slightly better. All right, so that's the general way. Of course, we can use technology to get a much nicer graph, right? But the idea is to be able to do these using our own brain and our own intelligence. Otherwise, we can pretty much program any robot to do things in a computerized manner, but that's not going to do a whole lot for our intelligence, is it? So let's say this. Let's say, imagine for a second that I didn't just want you to graph it. I also wanted you to give me maybe at least 4 points on this circle. Let's say 4 important points. Let's call them the north, south, east, and west points, right? Would you be able to do that? That's the question. Well, it wouldn't be that difficult, right? Because we know where the center is. The center is at negative 3, 5, right? So the east and west points, they're going to have the same y value, right? So that's the easy part. We'll start with that. Now, to get the x coordinate here, all I have to do is take the negative 3, and how far did I go to the right? 4 units, right? Just add 4 to it. So what is negative 3 plus 4? That's 1. Now you can see that on the graph, but you can also figure it out very simply in this manner, right? So that'll be 1. Now, to find out what this x value is, what do? You start at your -3 and you subtract 4. So you get to what? -7. Again, -3 minus 4 is -7. All right, to get the north point. Now, we know that the north and south point will be at the same x value, right? So we'll start with the easy one. Now, to get the y coordinate of the north point, remember we start at the y value 5 and we went up 4, right? So we add 4. So it'll be what? 5 plus 4. That's 9. To get the south point, we start at 5 and we take away 4, right? We could subtract 4. So 5 minus 4 is, of course, 1. All right. Now, you may think, why do I need to go through all this? I can just look at this and tell you what those points are, right? Well, that's because these are nice whole number points, right? But when you know the technique, when you know the strategy, then you'll be able to handle it even if those points are not very nice. Let's say they're fractional or even irrational, etc. You'll be able to handle it, okay? So there is that. The next thing we want to look at is another form of the equation of a circle, which is very good for the purposes of classification of circles, but not as useful as the center radius form. Just as, for example, with lines, the slope-intercept form was the most useful form, but the form that we used for generalization was ax plus by equals c, right? That was the general form of the equation of a line. So this is going to be kind of in a similar spirit. All right, so the general form of the equation of a circle is given by this form. This comes from simply taking the center radius form and applying some algebra and getting rid of the parentheses and just going ahead and handling the squaring of the x minus h and the y minus k, etc., and then moving everything to the left side. So it's not some kind of a magical form. It basically is very closely related to the center radius form, and in fact we can go back and forth with these forms, as you will see. And here basically d, e, and f are just some real numbers. All right, as we said, the equation right here, the general form, can always be converted to this center radius form. And we can determine whether an equation of this form represents a circle, a point, or whether the graph is non-existent, dependent on the value of r squared once we do the conversion. Now, if r squared is positive, the graph is going to be a circle. If r squared is 0, then the graph is going to be a point. Some people like to think of a point as a circle of radius 0, but given that we do not allow radii that are not positive, we want to stay away from doing that. But I mean, intuitively speaking, if you want to think about it that way, is it wrong? Not really. It's kind of that what it is, right? A point can be thought of as a circle of radius 0, but just, you know, we don't formally do it because that would require changing a lot of definitions and a lot of theorems. We'd have to give justifications, etc., for radius being 0, adding special cases. So in order to avoid all that, we don't allow circles which do not have a positive radius. And if r squared ends up being less than 0, then the graph is not going to be existent. In other words, it's not going to be an actual physical circle that you can draw. Because if think about it, if r squared is negative, right, that means r is going to be an imaginary number, right? So that's why it's not going to have a real graph. Okay, next we want to find the center and radius of the circle represented by the given equation. Notice that here we don't need to do the r² test because we are told that this is a circle and we can trust that. So we're basically going to learn the procedure of converting this general form into the center radius form first. Okay, so we will do problems where we're going to be doing some testing, but this is not one of them. All right, so here the procedure is simple. We're going to put the x terms next to each other. So x² minus 12x, and we will leave a little bit of space because we're going to be completing the square, and we're going to put the y² plus 4y together. Again, we'll leave some space, and we'll have -15 on the other side already. Now this may seem familiar to you. If you recall, we did this with parabolas when we took their quadratic form and turned it from their general form into the vertex form. So it's very similar in procedure to that. So now we're going to go ahead and complete the square on x² minus 12x. Remember, that is a two-step process. First, we take 1/2 the coefficient of x, which is -6, and then we square that. So 36. So we're going to need to add 36. And of course, because this is an equation, as soon as we do something to the left side, we need to do it to the right side as well. Now we're going to complete the square on y² plus 4y. Again, we take 1/2 of 4, which is 2, and then we square that. So we get 4. So we add 4. So we also need to add that 4 on the other side. Now, on this side, we now have a perfect square trinomial, which of course is going to be the perfect square of x minus 6. And if you notice, the first step in completing the square for the x terms, we got a -6. That's how you know what goes in here. That's a good way to remember what should go in there. And of course, if you know how to square x minus 6, it all makes sense anyway, because remember, you have f minus l, quantity f minus l squared equals f² minus 2fl plus l squared, right? So it's remembering all that from algebra. All right, and here we have a perfect square trinomial as well. It is the perfect square of y plus 2. And on the other side, we're just going to combine all those numbers. So we have -15 plus 36, so that should give us 21, plus 4, that gives us 25. All right, so we just converted this general form circle into a standard form circle equation. So we can obtain the center now. Remember, whatever comes after the minus sign here is going to be h. And whatever would come after a minus sign here would be k. Since it's y plus 2, remember, you can think of y plus 2 as y minus -2. So what would come after a minus would be a -2. So k is -2. And this is the square of r, so r would be the square root of that, so it would be 5. So the center is at 6, -2, and the radius is 5. All right, so make sure you understand that procedure, and then we'll look at another one. All right, here's another one. This one is a little bit different because the lead coefficient is not 1. Now we do know that it represents a circle, so we want to get to the right form, which of course is x minus quantity x minus h squared plus quantity y minus k squared equals r squared. And of course, in order to get here, we are going to need a lead coefficient of 1, because that's basically going to turn out to be x squared minus 2xh plus h squared, right? So the first thing we're going to do is we're going to go ahead and divide both sides by 25. So let's show that like this. All right, so you know that this is going to split up, and each of these terms is going to get divided by 25, right? So we get x squared plus y squared minus 10 over 25. It'll be easier if we actually simplify that. 10 over 25, that's the same as 2/5, right? 5 goes into 10 twice, 5 goes into 25 5 times. So minus 2/5 x, and then plus 10 over 25, we know that's 2/5 as well, y minus 79 over 25 equals 0. Okay, now we're going to proceed just like before. So we're going to take the x squared term and the x term, put them next to each other, and then we're going to leave some space. We're going to take the y squared and the y term, put them next to each other. Let's go ahead and move the negative 79 over 25 to the other side, so it becomes 79 over 25 positive. Let me get rid of this. All right, so what do I need to complete the square here? Same procedure. Take 1/2 of negative 2/5, which gives us negative 1/5, because the 2's will cancel out, and square that. So we get 1 over 25. All right, so this is for the x terms. We get 1 over 25. So immediately we'll add that to the other side. And also for the y squared plus 2/5 y, we're going to complete the square. So we're going to take 1/2 of 2/5 again, which is positive 1/5 this time, and we're going to square that to get another 1 over 25. So we need to add 1 over 25, and here we're going to add another 1 over 25. So here now we have a perfect square trinomial. It's the square of x plus 1 minus 1/5. Be careful. Remember, this sign will tell you what that sign is going to be as well. So minus 1/5, and then you square that, and then plus, we have a perfect square trinomial here. It's the perfect square of y plus 1/5 this time. And on the other side, we have all same denominators, so we just add the numerators, 79, 80, 81. So we get 81 over 25. So we basically have accomplished our goal. So remember, the center here is going to be 1/5, comma. Be careful here because it's positive. You want to write it as a minus, so the k is actually negative 1/5. Now there is a quick way of thinking about this, but I don't want you to memorize it. I want you to really understand it. Basically, whatever number you see here, the opposite is going to go into the center ordered pair, right? You see negative 1/5, that's going to be 1/5. But you see positive 1/5, it's going to be negative 1/5. You're going to want to write, right? And the radius is going to be basically, this is this 81 over 25 is the square of the radius. The radius is going to be the square root of that, right? So we get 9/5. All right. So there is the center and radius of that circle. That's how you handle it when the lead coefficient is not 1. Get rid of whatever you need to get rid of to make the lead coefficient 1, and then proceed as before. Okay, so make sure that you can handle a little twist like this before we proceed. All right, so in this one, we're not sure if this is going to be a circle or not. We have to test it. And remember, the way we test it is according to the rule we saw before. Let's go back and take a look at that real quickly. All right, so we're given an equation in the general form right here. We're going to convert it to this form, and then depending on the value of r squared, we'll make one of these determinations. If it's positive, then the graph is a circle. If it's 0, the graph is going to be a point, and if it's negative, the graph is not going to exist. So the procedure is going to be the same. We're going to complete the square on x squared plus 12x, and then also on y squared plus 6y. We're going to move the 41 to the other side. It becomes negative 41. So here, to complete the square on x squared plus 12x, we take 1/2 of 12, which is 6, and square it to get 36. So we need to add 36 there. We immediately add 36 to the other side so that we don't forget. And for completing the square on y squared plus 6y, we're going to do the same. We're going to take 1/2 of 6, which is 3, and then we're going to square it to get 9. So we need to add 9. So immediately we add 9 to the other side to keep the balance. All right, so on the left here, we have a perfect square trinomial here. So that's going to be the perfect square of x plus 6. And this one is going to be the perfect square of y plus 3. And over here, we have negative 41 plus 36, which is negative 5 plus 9, which is 4. All right, so you know the trick now. Whatever you see here after x, take the opposite for the h value. And whatever you see after y here, take the opposite for k. Since they were both positive, these are going to both be negative, right? And this, of course, is the square of the radius. So the radius is going to be the square root of that, which is 2. So notice that r squared, which is 4, is greater than 0. So we knew we're going to have a circle. And in fact, we specifically defined it here. It's going to be a circle of radius 2, centered at negative 6, negative 3. Why don't you try this one on your own first before you come and check your answer. All right, so again, same procedure. We have x squared minus 2x, leave some space, plus y squared minus 10y, leave some space, and take the 26 to the other side, right? We need to complete the square on x squared minus 2x, so we take 1/2 of the coefficient of x, which is negative 1, and then we square it to get 1. So we need to add 1, and we immediately add 1 to the other side. On y squared minus 10y, we need to take 1/2 of negative 10, which is negative 5, and then we're going to square that to get 25. So we need to add 25 to those two terms to that binomial to make it a perfect square trinomial. and on this side we're going to immediately add the 25 as well. All right, so now we have this perfect square trinomial, which is a perfect square of x minus 1, and this trinomial squared, perfect square trinomial, which is the square of y minus 5. And on that side we have 26 minus 26, which is 0. All right, so the graph is a point. Can you tell which point it is? It's the point exactly 1, 5. There it is. So the graph is a point. How do we know that? Because r squared is equal to 0. Therefore, we knew that the graph is a point. In fact, we know what point. It's the point that would have been the center of a circle had this not been what? Had this not been 0. Since it is 0, it's just going to be the point 1, 5 all by itself. All right, so make sure you understand that, and then we will proceed. Remember, sometimes you need to rewind, etc., and that's perfectly fine. All right, here's an interesting application. Suppose receiving stations A, B, and C are located on a coordinate plane at the points 1, 4, -3, -1, and 5, 2. Let distances from the earthquake epicenter to these stations to be 2 units, 5 units, and 4 units. So in other words, station A is 2 units from the epicenter, station B is 4 units from the epicenter, and 5 units, and the station C is 4 units. And we want to know where on the coordinate plane the epicenter is. If you think about it, if you draw a circle at each of those stations of a radius given, like for example for A, draw a circle of radius 2, for B, draw a circle of radius 5, and for C, one of radius 4, because that's what the distance was, right, from the epicenter for each one. Then the point of intersection of those 3 circles is precisely going to be the epicenter of the earthquake that you're looking for, and you can see that that would be the point 1, 2. So it would be located at 1, 2. Now you can easily check to make sure that you've found the right one, because what you would have to do is you would have to find the equation of these circles and make sure that this point is actually on each of those circles. So for example, for the first one with center at 1, 4 and radius 2, that's what this circle is. For the second one, we have center at -3, -1, and the radius is 5. For the third one, we have center at 5, 2, and the radius is 4. So the equation for the first circle around the first station is going to be x minus 1 squared plus y minus 4 squared equals 2 squared, which is 4. For the second station, the equation of the circle that's 5 units away from it is going to be x plus 3 squared, because it's -3 and -1, so plus y plus 1 squared equals 25. And for this one, we're going to have x minus 5 squared plus y minus 2 squared equals 16. Now I'm getting lazy by not saying quantity sometimes, but you know what I'm talking about, so we'll be okay. All right, so now we're going to substitute 1, 2 and make sure it satisfies each of these equations. So this one, we're plugging in 1 for x, right? So that's going to zero this out. And we're going to plug in 2 for y, right? So 2 minus 4 is negative 2 squared, which is 4. So it satisfies this equation. For this one, when we plug in 1, 2, right? Notice that we end up with 1 plus 3, which is 4 squared, plus 2 plus 1, which is 3 squared. We're trying to see if that's equal to 25, right? Now that's 16 plus 9. Is that equal to 25? Yes, 25 is in fact equal to 25. That one is correct as well. And this one, we're plugging in 1, 2. Remember, 1 for x, 2 for y. Now, that's going to be easy too, because that's going to wipe this out, because y is 2. 2 minus 2 is 0 squared is 0. Now, plug in 2 here, you get 2 minus, plug in 1 here. 1 for x. 1 minus 5 is negative 4. Square that, you get what? You get 16. So that checks out as well. So there's a quick, nice application of circles when it comes to the epicenter of an earthquake and stations that are the receiving stations. All right, so make sure you understand that, and we will proceed. All right, so here's the last problem for the road. We want to find all values of y such that the distance between the ordered pair 9y and ordered pair negative 7, 7 is 24. Well, this is indirectly kind of related to circles, because you can think of this as being the center of a circle, right, of radius 24, and you want this to be a point on that circle. So in other words, you want this distance to be 24. So a quick application of the distance formula will solve this for us. However, notice that we don't need to deal with square roots, because we're actually going to use the definition of a circle to handle this, which is nice, because then we don't need to deal with square roots. So we're going to say x2 minus x1 squared, quantity 9 minus negative 7 squared, plus y minus 7 squared equals 24 squared. Just plugging into the equation of a circle. Remember, circle of radius 24, centered at negative 7, 7 with that point on it, right? So 9 minus negative 7, that becomes 9 plus 7, which is 16. So 16 squared plus quantity y minus 7 squared equals 24 squared, which I believe should be 576. So let's see. Yeah, it is 576. All right, so now we have quantity y minus 7 squared equals 576 minus 16 squared is 256. So we get quantity 1y minus 7 squared equals, I was looking at those numbers earlier, let me see if I have that. Yeah, so that's 320. Now, we can apply the square root property. Remember, if x squared equals k, then x must be what? Plus or minus square root of k. So here we get y minus 7 must be plus or minus square root of 320. And y is going to be 7 plus or minus square root of 320. Being a math class, you know, we always like to simplify as much as possible. So let's go ahead and find the prime factorization of 320. 2 goes into it 160 times, 2 goes into it 80 times, 2 goes into that. 40 times 2 again gives us 20. 2 gives us 10. 2 gives us 5. And 5 gives us 1. Once we reach 5, we're finished. So notice we have 1, 2, 3, 4, 5, 6. So we have 6 factors of 2. That's 2 to the 6, which is 64. So this can be written as square root of 64 times the square root of 5, right? And we get y equals 7 plus or minus 8 radical 5, just like that. Because when you do the prime factorization, what you get on this side is the factorization of that same number. So the product of all these prime factors will give you 320. So we can always split 320 into the perfect square part, which is all of that, which is 2 to the 6 or 64, and then times that. All right, so the values of y which satisfy this are those two values. One of them is y equals 7 plus 8 radical 5. The other one is y equals 7 minus 8 radical 5. All right, so that's a whole lot of information about circles. Circles, of course, are amazing figures, so it's good to know as much about them as you can. And that should do it for this video. So you take care until we meet again on the next one.